Lesson 5D is on completing the square. This is a topic that you're going to revisit later on in the year when we start doing conics. So it is a pretty important lesson that you understand. Probably not the most used when it comes to quadratics, but it gives you another option. The goal is to make a quadratic into a perfect square trinomial so that you can incorporate the idea of the square root method that we studied in lesson 5A and be able to solve your quadratic equation for x. Just to review, a perfect square trinomial is one that factors as the same set of parentheses for both factors, which means you can write it as a perfect square, whether it be a squared plus 2ab plus b squared, or whether it be a squared minus 2ab plus b squared. Either way, when you factor it out, you're going to get either the a plus b times the a plus b, which gives you a plus b squared, or you might get a minus b times a minus b, which gives you the a minus b squared. So, in order to complete the square, the first thing you want to do is to get that constant over to the other side. This is the only method that we were doing where you don't want to set it equal to 0. So once the constant's out of the way, you take you want to make sure you don't have any leading coefficients. We'll talk about that later because you can't complete the square if there's a leading coefficient. So you make sure there's no leading coefficients, and you take half of your b term and you square it. And you're going to add that value to each side of the equation. Then you're going to rewrite so then what you're going to be left with here is a perfect square trinomial. And you'll rewrite that as the perfect square trinomial. Then once you have a perfect square, then the way you get rid of the square is you square root each side. You want to make sure that when you're doing this that you don't forget your plus or minus, just like we learned in lesson 5A with the square root method. Anytime you put a radical into the problem that wasn't initially there, you want to make sure you always put a plus or a minus with the answer. And then we'll simplify each side. Now just keep in mind that you cannot complete the square of a trinomial that has a leading coefficient. So if there is one, you want to factor it out. But we'll do some examples with that. If you look at our first example, we don't have a leading coefficient, and it happens to be that our constant is already on the other side, so that step's been done for us. So where we're going to start is we're going to take half of our b term, which is negative 10. Half of that gives you negative 5, and you square it. So we're left with x squared minus 10x, and half of negative 10 is 5. Negative 5 squared gives you 25. But if you add 25 to the left-hand side, you want to make sure you add 25 to the right-hand side, because it is an equation and you want to keep it balanced. Okay? So now what we have here is a perfect square trinomial, and that will always happen when you take the half and square it. So we can write this as x minus whatever that half amount was, which in this case it was the 5 squared, and then our right-hand side gets simplified to being 100. So now we're right back to lesson 5A where you were doing the square root method. So I'm going to choose to put a square root into this problem, which if I put it on the left, I have to put it on the right too. That's going to give me x minus 5. That's going to give me plus or minus 10. It is imperative that you remember your plus or minus. This is what's going to give you the two answers instead of just one. And then in order to solve for x, we're going to add 5 to each side. And then we get 5 plus or minus 10. So that's going to give us two answers. 5 plus 10 gives you the 15. And 5 minus 10 gives us a negative 5. So this is a pretty clean answer. We don't have any radicals to deal with. And you can check these by substituting them back in. 15 squared minus 10 times 15 is going to give you 75. And then negative 5 squared minus 10 times negative 5 is also going to give you 75. So our answers would be x equals 15 and x equals negative 5. Alright, so if we look at a separate example, this one does not have the constant on the other side, so we're going to want to move that constant right here. We're going to want to get that over on this side before we can complete the square. So we have x squared plus 6x equals, and then we have a negative 4 because we move it. So we're going to take half of our 6, which is 3, and we're going to square it, which is 9. But if you add a 9 here, you also need to add a 9 here. You want to keep it a balanced equation. So x squared plus 6x plus 9 is a perfect square trinomial. It always factors as x plus that half amount, which we said was 3. And then negative 4 plus 9 is going to give us the 5. Again, at this point, we're right back where we were. Get rid of the square with the square root. So we're going to get x plus 3 equals plus or minus the square root of 5. We solve that for x. Subtract the 3 to the other side. We get negative 3 plus or minus the square root of 5. You can't simplify the square root of 5, so we're just going to leave our answer in that way. Again, this is two solutions. One is negative 3 plus the square root of 5, and the other is negative 3 minus the square root of 5. Okay, let's try it out again. We want to get this constant over to the other side. So we have x squared minus 10x. And then we're going to have a negative 8 over here. Okay, take half of your negative 10 is going to be negative 5. Squared is going to give you 25. If we add 25 to the left, you want to make sure you add it to the right as well. This guy is going to factor as a perfect square trinomial. That half amount, if you remember, we said was minus 5. If you don't believe me, you can FOIL that out. X minus 5 times x minus 5 is going to give you this. When we simplify this, we're going to get 17. We want to solve for x, so we need to get rid of the square. We square root. We square root. So we know that x minus 5 equals plus or minus the square root of 17. We solve for x. Add 5 over, so we have a positive 5 plus or minus the square root of 17. That's two solutions. One of them is 5 plus the square root of 17. One of them is 5 minus the square root of 17. I can't simplify that any further, so I'm done with that problem. Okay? Alright, so just to throw in here that's not quite as nice, here we're going to have to take half of an odd number. So there will be problems that you encounter that will use fractions. Doesn't change how we do it. Alright, so we're going to move our 1/2 to the other side, giving us a negative 1/2. We're going to take half of 7, negative 7, which would be negative 7 halves. It's easier not to work in decimals. And then we're going to square that, which is going to give us a positive 49. 7 squared is 49 over 4. If we add 49 over 4 to the left, you want to make sure you add it to the right as well. So this is going to factor as that x minus 7 halves squared. And we're going to simplify this to 47 over 4. Got a common denominator, added the numerators. I want to get rid of that square, so I'm going to take the square root. I get x minus 7 halves equals the square root of 47. Remember, it's plus or minus over 2, because the square root of 47 I can't do anything with, but the square root of 4 gives me 2. Solve for x. I'm going to add the 7 halves to the other side. I'm going to get 7 plus or minus the square root of 47 all over that common denominator 2. So it wasn't really that much more difficult. So there's a fraction. You know how to work with fractions. All right, one last example. I put this one in here just so you can see what you're going to need to do if you're presented with a leading coefficient. All right, we talked about first step is moving that constant over. And we also said, hey, we're not allowed to have a leading coefficient, so you got to pull that out. So let's go ahead and get rid of it before we worry about completing the square. Divide by 3. Sometimes it'll be a fraction that doesn't reduce. Sometimes it will be. Doesn't really matter. I know a lot of people get scared when they see a fraction. Okay, so we're ready to complete the square. We no longer have the leading coefficient. We take half of -1, which is -1/2. We square it, we get positive 1/4. We need 1/4 over here. You also need it on the right hand side as well. So this is going to give us x minus 1/2 squared. This is going to give you -7/4. So we're working with the square root of a negative number, which tells us we're also going to be picking up the other lesson we just worked on, and we're going to have an imaginary answer here. It's not imaginary because it was a leading coefficient. It just happens to be that this one involves the square root of a negative number. Doesn't have anything to do with that leading coefficient. X minus 1/2 equals plus or minus I square root of 7 over 2. We need to add the 1/2 over, so you're going to get x equals 1 plus or minus I square root of 7. And we have a common denominator between both terms of 2. And that would be our final answer for that one.